Hey Sam, this is David. We're going to do number 12 here. I'm using a program called WabbitEmu, which is an emulator for a TI calculator, and it's free, so I'll link it for you if you want to put TI-84 on your computer. So we're looking at tangent of x plus pi over 4. Let's go ahead and graph it on our calculator. To do that, you want to hit y equals, which is up in this corner, then hit tangent. X is this button right here, plus pi. To get to pi, it's right here in blue, so you have to hit the blue button first, then that, and then divided by 4. Now, if you go to graph, which is up here in the right corner, you might get one where you can see it, but if you don't see it, because your window might be a little bit messed up, you need to fix your window. One thing you can do is hit zoom, and then go down to number 6, or you can just hit 6 to select it. Zoom standard will put it in from -10 to 10 in both the X and the Y, which is what I had. And of course you can fix the window if you need to in the window if you want to see it a little differently, but this kind of shows what's going on here. You can see we kind of have a copy of itself a bunch of times. In fact, it goes for an infinite amount of times, both left and right. You can see it starts down at negative, keeps going this way to negative infinity, but it goes up, kind of changes concavity right here at this point on the x-axis. Then it goes up for infinity, and then there's an asymptote, even though it's not there. There's an asymptote straight down right here at this x value, where it jumps down to negative infinity and does the same kind of stuff. Okay, and so you can see it's basically the same from here to here, like a carbon copy of itself over and over again. Anyway, let's actually answer the questions. I'm actually going to start with the vertical asymptotes because there's a lot of them. In fact, there's an infinite amount. The reason why this has vertical asymptotes is because if you remember, tangent is actually sine over cosine. So I could write this function, instead of writing as tangent, I could write it as sine of x plus pi over 4 divided by cosine, which is a fraction. And if you remember from grade school, you can't divide by a negative. That's what's creating these asymptotes, is when the bottom, or this cosine, is equal to 0. So to figure out where that happens, I'm actually just going to set them equal to 0. I'm going to set cosine of x plus pi over 4 equal to 0. Now, if you go to your unit circle and you find all the points where the x value is 0, you'll notice at the very top of the circle and the very bottom of the circle is when that happens. And so those values are pi over 2 and 3 pi over 2. But those aren't the only two values. Those are just the root values. Like we mentioned before, you can keep going around the circle to get more. So that's why there's ends up being an infinite amount. You could take these and actually add 2 pi to either one of them, or subtract. So actually, I'm going to put it out here: plus or minus 2 pi from either. And you can do that as many times as you want to. So anything in the form of like 1 pi over 2, 3 pi over 2, 5 pi over 2, 7 pi over 2, 9 pi over 2, 11 pi, any odd number pi over 2 is going to produce an asymptote. Now, it's actually, that would be if we didn't have this pi over 4. Since we have this pi over 4 here, what we need to do is we need to actually set that x plus pi over 4, the inside part, equal to each of these things and solve. It's pretty easy to solve. Over here on the left, we could subtract pi over 4 on both sides. We'd have to get common denominators here. But anyway, for this one, we'd get, oops, if we solved x equals pi over 4. And for this other one over here, we get x equals 3 pi over 4. No, I'm sorry, 5 pi over 4. Excuse me. There we go. And again, we can plus and minus 2 pi as many times as we want. I'm actually going to write 2 pi. I'm going to write 2n pi. And same thing here, plus or minus 2n pi. Okay. So those are where the asymptotes happen. For the domain, it's all real numbers except the asymptotes. Asymptotes. There we go. So it goes left and right forever, but you don't want to include the asymptotes in there, which are all in the form of pi over 4, 5 pi over 4, 9 pi over 4, 13 pi over 4, and it goes to the negative side too. Negative 3 pi over 4, negative 7 pi over 4, and so on. Now for the intercepts, turn this back on here. There we go. Oh, I'm sorry. For the range, it goes up and down forever. So that's all real numbers. Okay. For the asymptotes, that's what I just did. So it's really here. This is your answer for the asymptotes. Now, for the intercepts, that's when the top is equal to 0. So that's when this sign is equal to 0. So we kind of do the same thing we just did, except now we set the sign of x plus pi over 4 equal to 0. And we solve it this way. Now if you look at your sign is the y value, so if you look at your unit circle, that would be on the left, the far left and the far right of your circle. So it starts at 0 and pi, and then 2 pi, 3 pi. So anything in the form of n times pi, and it would be negative as well. So we got 0, we've got pi, we've got 2 pi, 2 pi, 3 pi. Of course, you can go the other way too, negative 1 pi, negative 2 pi, So anything with an integer times pi is where it ends up being 0. But again, we have this little shift here, this plus pi over 4. So you need to take these and set them equal to x plus pi over 4. Set it equal to each of these things. Actually, we'll use pi. So we subtract pi over 4 on each side, which gives us x equals 3 pi over 4. And we can plus and minus pi from that. So we could get 7 pi over 4, 11 pi over 4, 15 pi over 4, and we can go the opposite way too. Negative pi over 4, negative 5 pi over 4, all that good stuff. So there's an infinite amount of x-intercepts. There's also a y-intercept here. To get that, you just plug in 0 for x. And so we get tangent of 0 plus pi over 4, which is pi over 4. And you can use a calculator for that, or use your unit circle. I believe it's 1. Now, intervals where it's increasing or decreasing, this is actually increasing as you move left to right all the time. It's never decreasing. Because it makes that jump to negative infinity, it's always increasing. So you can just write always increasing, never decreasing. And for periodicity, I'm not really sure what they're getting at, but I think what your teacher wants is how far is it from node to node. So these x-intercepts, how far apart are they? And they're pi away. So the period here would be pi. That's when it starts repeating. It repeats itself after every pi interval. Okay. I hope that helps. There's other ways to get the intercepts. For example, but you're not going to get nice numbers. You're going to get decimals. But you could hit second calculate and go down to 0. And let's say I wanted this 0 right around here. You pick a point to the left. You put your cursor to the right.